really stop to think about what's happening when you click a link? I mean, how does your computer find a server on the other side of the planet in like a fraction of a second? It feels like straight up magic, right? But it's all thanks to this little box you probably have sitting in your house right now, the router. To really get how it works, let's follow a super simple story about a guy named Johnny who really just wants a cup of coffee. So meet Johnny. He's on a local network, kind of like the Wi-Fi you've got at home. He can chat with his friends Mark and Lisa, no problem, because they're all hooked up to the same device, a switch. You can think of a switch as a small, private little club. It only connects people who are already inside the same building. Easy enough? Let's think of these networks as two totally separate neighborhoods. Johnny's neighborhood is on, let's call it, 10.1.1 Street, but the coffee server, it lives in a completely different part of town, on a street with a totally different name. The rule is simple. If your IP address is on the same street, you're local. If not, you're an outsider. And here's the problem, right? Johnny wants that coffee, but the website is on a server in that other neighborhood. His local switch, the one connecting him to Mark and Lisa, only knows about his own little street. It has absolutely no clue how to get a message to that other network. So, what's he supposed to do? Well, he's going to need some help. He needs a special device, a gatekeeper, whose whole job is to connect different neighborhoods together. He needs a router. And this, right here, this gets to the absolute heart of it. A switch is a local expert. It only connects devices in the same network, and it does that using their hardware address, something called a MAC address. But a router? A router is the long-distance specialist. Its job is to connect different networks, and it thinks in the language of IP addresses. Okay, so before Johnny can even think about reaching the outside world, we have to figure out how he talks to someone right next door, like Mark. Understanding this local chit-chat is actually the key to the whole thing. So every single device on your network, your phone, your laptop, everything, has a unique MAC address that's burned right into its hardware from the factory. Just think of it like a permanent house number that can never ever be changed. And that local switch, it only understands this local language of house numbers to get messages from one device to another. So we've got a little puzzle. Johnny knows Mark's IP address, which is like knowing Mark lives somewhere in the neighborhood. But to actually deliver the message, the switch needs his specific house number, his MAC address. So how does Johnny find it? He uses something called ARP, the Address Resolution Protocol. And honestly, it's pretty simple. Johnny's computer basically just shouts out to the entire network, "Hey, who here has the IP address 10.1.1.2?" The switch makes sure everyone hears this shout. Lisa hears it and ignores it. But Mark's computer goes, "Oh, hey, that's me. Here's my house number." And just like that, bingo, Johnny has the MAC address he needs to talk to Mark directly. All right, local communication sorted. Now, let's get back to what we really care about, the coffee. What happens when Johnny tries to reach that server in the other neighborhood? And here's where it gets really clever. Johnny's computer looks at the coffee server's IP address and it instantly knows, hey, this isn't on my street. It recognizes that it's not part of its own 10.1.1 neighborhood. It knows it can't just shout for it like it did for Mark. It has to send this message out of town. Now, to send a message out of town, every single device needs to know where the exit door is. In the world of networking, we call this exit the default gateway. And it's nothing more than the IP address of the local router, the one device that knows how to talk to the big, wide world. You know, as the source material puts it, Johnny knows the coffee server isn't in his neighborhood. He can't just walk over there. He's going to need some help to get to that other network. So how does he get that help? He uses that exact same ARP process we just saw. But this time, instead of shouting for Mark's MAC address, he shouts, "Hey, who has the IP address of my default gateway?" And the router is the only one on the network that raises its hand and says, "That's me," giving Johnny the specific house number he needs to send his coffee request to the right exit door. Okay, this is where the real magic happens. The message has made it to the router, our gatekeeper. So how in the world does the router know where to send it next? Well, it has a map. When the router gets that packet from Johnny, it's kind of like a mail carrier getting a letter. It completely ignores the local delivery info, that MAC address that just got the packet to the router. Instead, it looks straight at the final destination, the big IP address written on the outside of the envelope, the coffee server. And this is the router's map. It's called a routing table. And for our example, it's incredibly simple. It just says, hey, for any address in Johnny's neighborhood, send it out port 1. And for any address in the coffee server's neighborhood, send it out port 2. That's it. So the router just looks at its little map, sees the coffee server's IP address belongs to the network out on port 2, and it just forwards the packet out that port. It sends it on the next step of its journey. That is its entire job. Simple, right? Okay, now let's zoom way, way out. We just followed one little data packet on its quest for coffee, but this exact same principle is what makes the entire global internet work. See, the internet isn't one big cloud. It's a massive network of networks. Your home router connects to your internet provider's router, which connects to another one, and another one, and another one. And each one just looks at its map and pushes your data one step closer to where it needs to go. And remember that super simple 2-line map we saw on our little router? A real heavy-duty router on the internet backbone doesn't have 2 routes. Its map has over 800,000 routes to networks all over the globe. It's the same idea, just scaled up to a mind-boggling level. So, if you're going to take anything away from this, it's these 4 things. 1, switches are for local traffic using MAC addresses. 2, routers connect different networks using IP addresses. 3, your default gateway is just your network's front door. And 4, routers use that map, the routing table, to point traffic in the right direction. And this isn't just a story about Johnny. This is exactly what is happening for you right now. For you to even see this, your computer sent a request out through its default gateway. It got passed from router to router to router across the internet until it finally found the server where this content lives. Which really just leaves you with one final thought, doesn't it? Hundreds, maybe thousands of routers, each with a gigantic map of the world, all working together in less than the blink of an eye, just to get this to your screen. What incredible, invisible journey did your data just take?